Good morning, and let's go ahead and talk about order of operations. Okay, and order of operations is super important to all mathematics because if we didn't have order of operations, we might all end up getting different answers. Now, when you're thinking about just a math class, it doesn't seem quite as important. But when we're talking about maybe now building an airplane, it's really important to make sure that we're all ending up with the same values, so we make sure that we end up with our final build and our final calculations of an airplane that functions properly. So first, let's go ahead and talk about three really important words that are going to come up a lot in this chapter. We have solve, which is to find the solution to something. A lot of times you're going to see the word solve when we're talking about solving an equation. Maybe we have something like 2x plus 5 equals 12, and we want to go ahead and solve for x. We want to find out what is that value of x. We also have to simplify, which means we're going to put an expression in the simplest format possible. Oftentimes, if you hear simplify the expression, we're talking about combining like terms. And then lastly, we have evaluate, and that's what we're going to be looking at today when we're finding an actual value of an algebraic expression. Okay, when we're simplifying things, most often it has variables, so we can't actually evaluate or solve for anything because we have unlike terms that we aren't able to combine. But evaluating, we're actually finding the value of something using order of operations. This could also apply to when we're substituting in a value. Maybe we're looking at a graph, which we're going to look at later on in the semester, and we're trying to find what is the value of y when x is 7, something like that. Okay, so order of operations, that's our main topic for today. A lot of times you're going to hear PEMDAS for order of operations. A couple of reasons why I don't like to just say PEMDAS. Number one, P normally stands for parentheses, where parentheses is not the only type of symbol that is considered first. Parentheses, brackets, braces, all of those are considered a grouping symbol. Okay, the other reason I don't like just saying PEMDAS is because that implies that addition always comes before subtraction, or multiplication always comes before division. That is not the case. Multiplication and division are on the same level, and we always work whatever comes first, left to right. Same with adding and subtracting, whatever comes first, left to right. So let's go ahead and get started. We're going to look at 4 problems here. We're going to go from simple, and we're going to go ahead and get more difficult as we work. So first, we want to think grouping symbol. Well, here's some parentheses right here, but these parentheses are only acting to hold in that 2 and showing that this 3 and the 2 are being multiplied. So that's not counting as a grouping symbol that we need to evaluate. So next we look for exponents. There are no exponents. So we move on to multiply and divide. Remember, we work left to right. So division actually comes first, left to right. Now, when I do order of operations problems, I like to actually underline what step I'm doing, so I know to copy down the rest of the steps. So 54 divided by 3. So that gets me 18. And then carry down my times 2. We have addition and multiplication left. Multiplication comes first. So 18 times 2 gets me 36. So 7 plus 36. Now I can go ahead and add those two values together. And so I get that 43 is what I get when I evaluate that expression. Okay, next example, parentheses or grouping symbols. We don't have any. So next comes exponent, 2 to the 5th. Well, what that really means, I'm going to go ahead and do some kind of side math over here. That means 2 times 2 times 2 times 2 times 2. 2 to the 5th power. Now we can use a calculator. You can even use Google to type this in. I'm going to have another video on that. We could, if we wanted to type it into a calculator or Google, we would often type 2 caret 5. This caret symbol here is when you do shift and then the 6 key on your computer. We can also type it in as just 2 times 2 times 2 times 2 times 2 on a calculator or on Google. Or we could do it in our head. It's up to you. When we do 2 to the 5th, we get 32. So when I evaluate 2 to the 5th, I get 32. So we get 17 minus 32 divided by 4 plus 6. Okay, now I have subtraction, division, and addition left. Division is going to come first, so I'm going to do 32 divided by 4. So we get 17 minus 8 plus 6. Then addition, subtraction, left to right. All I have is addition, subtraction, so they're on the same level. So I'm going to do 17 minus 8. I get 9 plus 6. 9 plus 6, I get 15. And so 15 is what I get when I evaluate that given expression. Okay, let's go ahead and look at another one. We have 2 more examples here. Again, we're getting more complicated as we go. Now, this fraction bar right here, it's a really long fraction bar. This is actually called what we call a vinculum. It acts as a grouping symbol. I need to evaluate the numerator, the top. Then I need to evaluate the denominator or the bottom of my fraction. Then I can do that division that comes with that fraction bar. I'm going to go ahead and do my numerator first because it has a grouping symbol. So I need to evaluate what's in that grouping symbol first. Well, within that grouping symbol, I have subtraction and exponents. So what I'm actually going to do first is my exponents here. So I have 7, 2 squared. Well, that's 2 times 2. There's 2 of the 2's because of this 2 here. So that gets me 4 plus 17, and then copy down my whole denominator. I'm not going to worry about my denominator at all yet. I'm only going to simplify this numerator here. Then I need to continue with my parentheses here, my grouping symbol. So I get 7 minus 4, so I get 3 plus 17. I dropped my grouping symbol there because I don't need it anymore. I evaluated everything that was inside them. Then again, I'm just worrying about my numerator first because this fraction bar acts as a grouping symbol. So I need to do each individual part first. 3 plus 17, so I get 20 all over negative 14 plus 2 times 5. Now I can evaluate the denominator. I have adding and multiplying, so multiplying comes first. So I get 20 all over negative 14 plus 2 times 5 is 10. Negative 14 plus 10 is negative 4, so 20 all over negative 4. Well, when fraction bars, again, are just division, so 20 divided by 4 is 5. A positive divided by a negative is a negative. Circle my answer. So evaluating this expression, I end up with negative 5. Our last example. First thing I need to do is grouping symbols. I have these brackets here. I need to evaluate what's in here. Well, inside these brackets, I have now parentheses. So that's actually what I need to evaluate first. If I have 2 sets of grouping symbols nested within each other, I start with the innermost grouping symbol and work my way out. So I'm going to evaluate the 5 minus 9. So I get 20 squared. Just copy that. Divided by 3. 5 minus 9 is negative 4 squared plus 2. Well, these parentheses are now just holding in that negative 4, so I can do exponents because, again, I'm still concerned about these braces, what's inside the braces. So negative 4 squared, well, that's negative 4 times negative 4, which is positive 16. So I have, keep my braces, 3 times 16 plus 2. Again, continuing within these braces, now I have multiplication and addition, so multiplication comes next. So 20 squared divided by 3 times 16 is 48, plus 2. Continue on, last step within these braces is 48 plus 2. So 20 squared, 48 plus 2 is 50. I can now drop those braces because I've evaluated everything with inside of them. Now, lastly, the only thing I have left is exponents and division. Exponents come first. So 20 squared is 400 divided by 50. 400 divided by 50, so I get 8. So when I, again, evaluated this expression, I get 8. If you have any other questions about order of operations, please let me know.